Hello, welcome to Calculus 2, Math 112. Today, Lecture 5. Today's lecture is on inverse functions and their derivatives. In order to study inverse functions, it's important to be familiar with one-to-one functions. One-to-one functions require that if x2 and x1 are not equal, f of x2 cannot equal f of x1. So as you see, what we're doing is when we graph the function, we want to make sure that there's a one-to-one correspondence between x and y. We can use horizontal line tests and vertical line tests to check for this one-to-one correspondence property. We actually say that the functions f and g are an inverse pair if and only if you substitute g of x in place of x for f of x, you get x back. Similarly, if you look at g of x and you substitute f of x in place of x, you get x again. So what happens is that when you look at the composite of the two functions, you get the identity function. The composite of the two functions, no matter which direction it's taken in, will always give you x. Now, the notation that we use is that g is equal to f to the negative 1, and f is equal to g to the negative 1. And this notation allows us to write expressions for inverse functions efficiently. Now let's take a look at a specific example. Suppose that y is equal to x squared, where x is greater than 0. Then we can just solve for x as the square root of y. So f of x is x squared. G of y is y to the 1/2. We see that x squared to the 1/2 equals x, and x to the 1/2 squared equals x, just as we expected. So x squared and square root of y are inverse functions. Now here's another example of an inverse function. Suppose our original function x is equal to y squared plus 2y. We wish to solve for y as a function of x now. So what we do is we add 1 to both sides in order to complete the square on the right-hand side. We want to complete the square on the right-hand side, so when we add 1 to both sides, we get x plus 1 equals y squared plus 2y plus 1. Now that means that x plus 1 equals y plus 1 squared. Then I can take the square root of both sides, and I get y equals negative 1 plus the square root of x plus 1. Now I took the positive square root because of that need for a one-to-one correspondence. We want these to be one-to-one functions, so I had to restrict myself. I either take the positive root or I take the negative root. I take 1 so that I can maintain this one-to-one correspondence. So you can see that x given as y squared plus 2y and y given as negative 1 plus the square root of x plus 1 are inverse functions. Now let's talk about derivatives. The derivative of the inverse of f equals 1 over the derivative of f. So there is a rule where you can find the derivative of an inverse function by knowing the derivative of the original function. This comes from knowing the formulas for derivatives and also that the composite of inverse functions is x, the identity function. Now here is a nice mnemonic device that allows us to remember this important result. The derivative dy dx is not a fraction. It is a quotient of differentials, and thinking of it that way, we can also write that dx dy is just 1 over dy dx, providing of course that the derivatives exist and that the denominators are not 0. So we can actually write that the derivative of x with respect to y is just 1 over the derivative of y with respect to x. So if we know y is a function of x, we can find dx dy by just finding dy dx and taking the reciprocal. Now here is a nice example. Y is equal to 6x plus 11. That implies that x is y minus 11 over 6. What is dy dx? dy dx is 6. What is dx dy? dx dy is 1/6. You see that the dy dx and dx dy are reciprocals of each other. Now here is another example. Suppose that y is equal to x cubed. That means that x is equal to y to the 1/3. dx dy is 1/3 y to the negative 2/3. dy dx is just 3x squared. Now we can write 3x squared as 3y to the 2/3 because x is just y to the 1/3. So what you see once again is that dx dy and dy dx are reciprocals. You take the reciprocal of dy dx, you get dx dy, and so on. And if you multiply dx dy times dy dx, you get the identity. Everything will cancel out. You'll get 1. Okay? And that's a good way to test that you did it correctly. This ends our discussion of inverse functions and their derivatives. Thank you for listening.